Questions is it?
10, I think. You'll find out in about 3 minutes either way, so.
Yeah. 3 minutes.
Sorry?
Good time.
Is it timed?
Yes. Like
I mean, you don't have the whole period, but 45, 50 minutes is fine. Some people finish in maybe 15, 20.
Do you want me to take the quiz again? No, you don't need to take it again.
This will be, but
We are going to start on this. Wait, you did this already, didn't you? Yeah. Okay. So,
you're off the hook till tomorrow.
What's the retake policy?
No retakes.
Yeah.
It's important to you. You got to start putting in your full effort.
Where did you say you could find the calculators at again?
They're right here.
Okay.
You need to borrow one?
just leave this one on my desk when you're done.
Thank you, sir.
Alright, before we get started on our quiz today, this is our first assessment of the year.
So, I'm going to give you one last chance to still get full credit on 3, 4, and 5. So I asked you guys to turn that into Google Classroom last time I saw you. 3 was the notes, 4 was the book assignment, 5 was the practice quizzes. So I don't know any reason why you wouldn't have that done, except maybe if you were finishing those up you planned on turning them in later, and then maybe your Wi-Fi didn't work or something. But if that meets your requirements, if you did not put them in Google Classroom, or if you're not sure, you should turn them into the in basket before we start, because they are due before we start the quiz. So if that applies to you, then please come give me what you need. Secondly, I don't take up phones during our normal classes, but on assessment days I do. So if you have a phone or a smartwatch, I need you to turn that in. So look at your seat number, and on the wall over there, there'll be a pocket that matches the same number on the far wall over there. So put your phones and smartwatches up. We'll get them back right after the quiz. So have them.
Should I put mine up?
No, you don't need to. But thank you for checking.
Determine what you have. We'll finish them later to get half of your points back. Only if you didn't go to the classroom.
I got Google Classroom.
Huh?
I put them on Google.
Okay, then you don't have to turn them in that way.
Okay.
It's just one last chance in case you weren't able to turn them in. Alright, and this morning you are allowed a calculator, using the calculator. And please go ahead and start as you get it. I would suggest you put your name on it before you forget. And I'm also going to suggest that you number it as number 6 for your binder. It usually takes about 1 week to get those back to you, because if somebody's absent, I have to give them a chance to take it during advisory before they get a 0. So I need everyone to have that chance before I pass them back. And so a week from now, you probably aren't going to remember that this is supposed to be number 6 in your binder. So put a big number 6 on the top right, and you know where it fits when you get back. And we often use anywhere from 2 to 5 different versions of our quizzes and tests. So please don't be tempted to look at your neighbor's paper. Not only will your answer be wrong, it's usually pretty obvious. And this one should have no surprises. At quick glance, you should see it looks like the practice quizzes we've been doing. So. All right, and then finally, before y'all get going too far on here, let me explain the process as you finish. I can give you about 45 minutes on this. This is a similar length quiz that we used to get before we had block schedule, and that's how long classes were, and that was enough time. So 40, 45, maybe 50 minutes is fine. But when you're finished, if you still have time left, I would check your answers. I do give partial credit, but not on questions that are 1 point each. So you can see on each question we give you the point values. 1 point questions are right or wrong. Everything else you can earn partial credit on. But when you finish, you're going to come bring it and put it in the basket up here. 1. 2, you're going to grab the next handout that we'll go over when the quizzes are done. And then 3, make your way around and grab your phone back. So you can pick your phone back up as soon as I have your quiz. Oh, yeah. And then just hand it to me when you're done with it.
Question?
You don't have anything from other class you can work on for tonight? I just hate to waste your time, so.
Yes. So if the question's in ratings, your final answer needs to be in ratings. If it's in degrees, your final answer needs to be in degrees.
Okay.
Same way you did in the book work. Thank you. Perfect. And then just get your phone before you sit back down. Quiz in there. Take the next handout, and then go pick up your phone before you go sit back down.
Put it in the basket.
Yep. In the basket, take the next handout, and grab your phone before you sit back down. And then you need this for after, and then pick your phone up before you sit back down. Good. Perfect. Thank you. Bless you. Wait. Did you get the notes? You need that for when we're all done. Thank you. Quiz in the basket and then take the next set of notes.
Click here and then take the next page. While everybody finishes up, those of you that are finished, just hang tight for a minute. You got something to work on for another class, that's great. You need to put your name on the board though, so you bring the pass back. Yeah, just anywhere. Or you can quietly play on your phone for a few minutes, but we still got a handful more people still working.
Could you check these things?
Yes. Those look good. I'll get it put in. Thank you. Put in the basket and then take the next set of notes.
I take one of yours.
I'm sorry?
I take one of yours.
Yes, please. And your phone too.
Just in your phone.
For those of you still working, I can give you up to 5 more minutes.
In the basket and then.
We need to move on. So again, first quiz of the year, so let me give a quick reminder. When you turned in your quiz, there was a handout I needed you to pick up. Did anybody forget to grab it? Because I will bring you one. Okay, and also, if you forgot to pick up your phone, please go and get that. I don't want you to forget it, and then on B days, this is my last class of the day, so I won't always be in here. I have meetings and stuff sometimes after, so if you forget it, it might be stuck in here all night. All right, also quick reminder on homework, if there was something that you lost or didn't complete, if there's something you got partial credit on because it wasn't completed, I want to remind y'all that you can finish it as long as I get it back completed before our first test, which is still a few weeks away, and you can get half of your points back. Likewise, if there was an assignment that I took up that you didn't have with you, or you didn't turn it in, whatever the reason is, bless you, you can still get half of your points after it's fully completed and you turn it back in. But it's got to be before the first test. All right, also I do have the quizzes graded, so those are in grade book if you're interested in how you did, but you do have to wait to see yours, so if it's going to bug you to not know what mistake you made, then you're going to have to maybe hold off. But so we move in. Our first unit here is actually over 3 sections, so what y'all just took a quiz over is about the first 1/3 of what your first test will be over. So when you get that quiz back and you see how you did, it gives you a good indication of what you need to review and study. Our second third is section 4.2, and almost all of this section is about the unit circle. There's a couple other little things in here, But I'm going to tell you some unit circle stuff, hopefully make a few connections for you, show you a few strategies so that you don't have to just straight up memorize the unit circle, make it a little bit more convenient. And then when we get to the back page, I'll show you how I keep up with the unit circle without memorizing it, and I'll give you a few example questions so you guys know what will be expected of you. A lot of times with unit circle, I say that and you guys think you know what it is because you can fill out this chart or you filled out this chart in other classes. But when you see how we use it, you're going to realize that you have to know it much, much more in depth. But before we even get to that, you need to know what unit circle means. So this is unit singular because it's a radius with length 1. So not units plural circle, unit singular because it only has a radius of 1. And I'm kind of surprised this doesn't come up in section 4.1, but trigonometry means the study of triangles. And if we do all this stuff with triangles, I would see why you might be curious why we care so much about the unit circle. So if you take this guy and center him like at the origin, and you pretend like he's touching the circle, that's often what we do. We're working within a circle, unit circle, but we can sketch and work with triangles within that. So the angle that we like to look at is this one right here, the one by the origin. And there's a couple ratios that you need to know where some of this is coming from, and so you know why the unit circle works some of the ways that it does. We actually will review SOHCAHTOA and how to use it in another section, but I need it a little bit right now. You guys, I'm assuming your geometry teachers use this acronym at some point. Yeah? Okay. So I'll remind you, the first 3 letters are a quick way to tell you that sine is always the opposite length over the hypotenuse. So opposite is directly across from the angle, and hypotenuse is the biggest side opposite the right angle. The middle 3 letters of SOHCAHTOA remind us that the cosine ratio is adjacent over hypotenuse. Adjacent's the side that's next to an angle that's not already the hypotenuse. And the last 3 letters are there to remind us that the tangent ratio is always the opposite length over the adjacent length. So again, you don't really have to remember that right now, but for you to understand where this next step's coming from, it's really just an extension of this. So not only can I call this opposite, but if I'm thinking of this triangle centered at the origin, this distance, I'm going left and up, this gives us a point. But the distance we're traveling left and right, sometimes we refer to as x. So instead of saying adjacent, we might say x. The distance I'm going up is y. So sometimes instead of saying opposite, we will say y. And what's another name for this hypotenuse? What else is it besides the hypotenuse of a triangle?
Radius.
It's also the radius of the circle. Good. This will actually be a small handful of things that I have to get you guys to memorize here in about a week or so. But for right now, just see how this could be y because it's the distance up or down. This could be x, the distance left or right. And not only is this the hypotenuse, it's the radius. The reason why I'm pointing this out to you is when we're talking about unit circle and r is 1, if r is 1, sine can just be y. And cosine can just be x. Y over 1 is y, x over 1 is x. So when we get to the back page and we talk about all of those points on the unit circle, really it's all the exact cosine values of those angles and exact sine values of those angles. And this is the reason why. I'm just showing you where it comes from. Now for tangent, since it's y over x, if sine is y and cosine is x, a lot of times with tangent we have to do this thing called the quotient identity, where we will take sine divided by cosine, and that's how we find tangent values. So I will refer back to this, but these 3 things are what I'm hoping you get out of this. These 2 so that you understand why they are what they are, and this one we'll use so much that you'll memorize it in no time. Now again, when we get to the back page, I guess you can be just as successful with the unit circle by just straight up memorizing it, but not everybody wants to memorize a whole thing just to use. So really there's 5 values that show up a lot. There's 0 and 1, which I don't bother typing up on your page because you guys know how big 0 is and you know how big 1 is. But then there's 3 other ratios that come up all the time. So if you know how those compare, then it gives you a good hint about what those values are without memorization. So if we think of these as their decimals, 1/2 is about is 0.5. Square root of 3 over 2 is about 0.866, and square root of 2 over 2 is about 707. I'm telling you those because when we look at the different links on the unit circle on the back page, other than 1, the biggest links will be square root of 3 over 2. You should be convinced it's the biggest because it has the biggest decimal. The next biggest links would be square root of 2 over 2. It has the next biggest decimal. And the smallest of the links, other than 0 of course, 0 is obviously smaller, is 1/2. It has the smallest decimal. So in each quadrant on the unit circle, we've got 3 different links. The smaller links are always 1/2, the medium links are always square root of 2 over 2, and the biggest links are square root of 3 over 2. And if you just know how those 3 things compare, then you can figure out those values in the moment without even really memorizing them. Now, just for your own knowledge, this won't be on any of our quizzes or anything, but I'd like for you guys to know where these ratios come from, especially since we use them for half of the year. So instead of just telling you, hey, this is what they are, I don't know. Sometimes in math, some of the stuff that we learn is because some mathematician said it's important, but these aren't just like some random numbers that are made up. So the connection is, at some point you guys learned about the special right triangles, 30, 60, 90, and 45, 45, 90. Sounds familiar? Okay, it's really just an extension of those. So I've been told the last few years that if you know these ratios, if you remember these ratios, it can help on the ACT, but I don't know. So in a geometry class, you probably didn't do too much with these, but there was a ratio for 30, 60, 90. For every 1 in length opposite 30 degrees, you have 1 square root of 3 opposite 60 degrees, and a hypotenuse of length 2. 1 to 1 square root of 3 to 2. Do y'all remember that? Okay. The different, well, let's just do this one too. 45, 45, 90. For every 1 opposite 45 degrees, you'd have to have 1 opposite 45 degrees. Those angles are opening up the same amount in the same triangle. And then does anyone remember this?
Square root of 2.
Very good. Square root of 2. Now, you might be saying, what in the world does this have to do with unit circle and these ratios? Well, if you imagine this is a triangle centered at the origin. Sorry, I know my circle sucks, but just pretend. We are interested in memorizing a bunch of stuff about the unit circle. And what does the unit circle mean? So I want to change this from a radius of 2 to a radius of 1. So what did I do to that side? Okay, divided it by 2, I halved it. And because these sides are proportional, if I divide this side in half, I have to divide this side in half and divide this side in half, which is where the square root of 3 over 2 and the 1/2 show up naturally. It's the same special right triangle you've seen in the past, but we're fixing the hypotenuse to a length of 1. We do the same thing with this guy. Pretend like he is centered at the origin. I really want to talk about the unit circle, so when the radius is 1. And for me to change this to 1, I divide by the square root of 2. But if I divide one side by the square root of 2, if the other sides are proportional, I should be dividing them by the square root of 2. Now, this doesn't look like one of the 3 values I gave you, because one thing that we will have to practice in this is called rationalizing. Do you remember if you rationalized in Algebra 2? Some? Okay. Basically, some parts of mathematics, especially trig though, consider a square root in your denominator unsimplified. So if you multiply the top and the bottom by that square root, it's like you're multiplying by 1, so we're not changing the size. But it always makes your denominator, like the square root of 2 times the square root of 2 would be the square root of 4, but then that becomes 2. So we don't look at it this way. We rationalize it and look at it this way. So again, you don't have to derive that from me. I just wanted you to know that if you really know your special right triangle ratios, if you change the hypotenuse to length 1, that's where 1/2 square root of 3 over 2 and square root of 2 over 2 just appear naturally. Okay, there's 2 more things before we actually construct a unit circle, and these things will seem a little bit more random, but I need you to have them documented for your notes so that you have a resource to look at when we move on to the book assignment, which won't be today, but we'll be able to do that tomorrow. So, looking at your calculator, look in the middle, and you need to see that there are 3 buttons: sine, cosine, and tangent. So a few of the questions we want you to do in this section is just straight up, can you use these in your calculator? So your calculator has sine programmed in, so it can tell us the sine of 29 degrees very simply, and the sine of pi over 9 radians. It can do that pretty easily as well. So in your calculator, let me do both. I'll put them both on the board. One is sine of 29 degrees and one is sine of, is it pi over 9?
Yes.
Okay. One of those answers is right and one of those answers is wrong. How could the calculator possibly get one of them right and one of them wrong? You got to pay attention to the mode you're in. My calculator's in degree mode. So when I ask it what's the sine of 29, it knows I'm talking about 29 degrees. If you hit your mode button, the third option down is how we switch those. So this one's fine. The sine of 29 is about 0.485. But this one's not right, because when I typed in the sine of pi over 9, my calculator thinks I mean pi over 9 degrees, which is kind of a weird degree, but it's possible. So for that one, you would need to go to mode, highlight radian, hit enter, and now when you do it, it knows pi over 9 is a radian, and now the answer is correct. So notice there was nothing obviously wrong with the decimal it was giving me the first time. You have to have the peace of mind. You've got to be thinking about your calculator is only going to give you the right answer if you ask it the right question. But sine of pi over 9 radians is about 0.342, and our calculator can just do that for us. 0.342. Just be careful with what mode you're in. You often have to check. If you have one of these older kind, if you have your own, unfortunately you just have to hit the mode button to even see what mode you're in. Some of the newer ones, it shows you up here, so it's kind of nice to know you're in radians without hitting the mode button, but either way. So our calculator has sine, cosine, tangent, but there's actually 6 trig functions. Did y'all learn the other 3 in Algebra 2 last year? You saw them at least? Good. All right, the other 3 are cosecant, secant, and cotangent. Now, your calculator doesn't have buttons for these because, well, first off, they don't want to make it have a million buttons, so they have to prioritize. But if you're working with secant, cosecant, or cotangent, you really should know how they relate to sine, cosine, and tangent. You don't need a special button. Cosecant is just the reciprocal of sine. 1 over sine is just an easy way to say reciprocal. Secant is the reciprocal of cosine. And cotangent's the reciprocal of tangent. Now, students usually pick up on cotangent and tangent quickly because they sound the same. The other two, you just have to remember which is which. My trick when I was your age in high school, I took the same class, although it was called something slightly different. I always thought it would make sense for sine and secant to be reciprocals because they start with S, and cosecant and cosine to be reciprocals because they start with C, but it doesn't work that way. It's switched. The letters don't match up. So your calculator does not have cosecant programmed in, but you just have to know that it's the reciprocal of sine. So you need to put this in your notes here. This is what we would put in our calculator. 1 over the sine of 35 degrees is the same thing as cosecant of 35. Yeah.
Up here in the Lewis, is there's a sine minus. What does that mean? Sine
That's
minus-
inverse. Inverse and reciprocals are not the same thing. Reciprocals are just where you flip your fraction over. So like later on we'll talk about the sine of 30 degrees is a half, which means the cosecant of 30 is just going to be 2. You just flip the fraction over. The inverse, which is what you're thinking of, we'll do a whole section on that later this semester. But inverse is like, I don't know. If this is a function, inverse is where you swap input and output. And it has, I mean, it's useful for other things too, but it's not the same as reciprocal.
Gotcha.
Easy to mix up though. So make sure, now I don't always give points for the notes like I did in the first section, but when I do, y'all need to have the important stuff down. This is how it gets typed in your calculator. When you go and do this out of the book assignment tomorrow, I don't mind what you guys ask, but that's how you do it. So 1 over the sine of 35 degrees. And that's not right because what? Because it's in radians. I know it's a pain, but sometimes you got to switch back and forth. Just be careful. And again, there's nothing obviously wrong with what I did the first time. It's about 1.743. About 1.743. So, of course, write the answer down too. But again, the answer doesn't mean anything. You don't care about that actual number in a week. You do care about how you find this, how it goes in the calculator. So what do you think we need to put in the calculator for cotangent of 5 pi over 11? Good. 1 over tangent of 5 pi over 11. And make sure your calculator's in radian mode, because 5 pi over 11 is in radians. So this is why the calculator company doesn't make secant, cosecant, and cotangent buttons, because if you're working with those, you need to understand these reciprocal relationships anyway. So if you know how to type it in, oh, sorry. I said it needed to be in radian and then I didn't follow through. There we go. It's about 0.144. Approximately. So sine, cosine, tangent just work because those have been programmed in. That's why they get their own button. Secant, cosecant, and cotangent, your calculator can do those also. You just have to know how to enter them in as reciprocals. All right, and then last thing, this one will also seem kind of random, but you'll see in the book assignment tomorrow why we need to know this. You need to know what it means to be an even and an odd function and which trig functions are even and odd. So let me start off with the algebra side of this, what you should have maybe learned in the past. An odd function, like maybe x cubed is an easy graph to learn, reminds me that if I plug in a point like, let's say 2, I get a y value of what? 8. But if I plug in a x value of -2, do I still get 8? What do I get instead? Right, the opposite of that, right? That's what it means to be an odd function. So in trig, 4 of our functions are odd. Sine and his reciprocal are odd. Tangent and his reciprocal are odd. And what that means is whether you plug in a positive angle or the negative version of that angle, positive angle compared to negative angle, it's not going to be equal, just like 8 was not 8. It's only equal after you multiply one of them by a negative. That's what it means to be odd. The sine of 30 degrees is not equal to the sine of negative 30 degrees. It's equal to the opposite of that. And then for even functions, a good one to memorize is x squared. Because you can visualize it and you can say, well, if I plug in 2, I get 4. But if I plug in negative 2, I still get 4. So what it means to be an even function, which is cosine and his reciprocal, is whether you plug in a positive angle or the negative version of that angle, they will be equal. The cosine of 30 degrees is going to be the same as the cosine of negative 30 degrees. Again, this doesn't really matter so much today, but I need you to have it correct in your notes so you have that as a resource. Ultimately, what I do is I remember that there's 2 even functions, cosine and his reciprocal, which means the other 4 are odd. And then eventually you need to know what it means to be even. Whether you plug in a positive angle or negative angle, it comes out to be the same. And you need to know what it means to be odd. If you plug in a positive angle and a negative angle, they're not equal unless you multiply one by a negative. Just like these 8s were not equal until you multiply one by negative. These 4s are equal. No need to multiply by negative. All right, and then finally, actually constructing the unit circle. And I saw some of you starting on this after your quiz, which I thank you for, because it never hurts you guys to kind of see what you already know. But all unit circle questions basically boil down to finding the location, step 1, knowing the point, and then knowing what x and y is. And then sometimes you have to do more work. But let's say by the time we're finished here, I want to do a small handful of questions of what you'll actually be asked. Let's say, let's aim for like cosine of 5 pi over 4 as our first question. For you to be able to do that, you have to know where 5 pi over 4 lands on the unit circle. So you can straight up memorize the unit circle, or you can take some of these tricks that I'm about to tell you. So let's work about, we'll come back to this. Let's work on the spots first. How many degrees is on the positive x-axis? 0. The angle's not opening up at all. And there's only 3 spots in quadrant 1 that we memorize. So all of these big jumps are 30-degree jumps, and all of the small jumps are only 15-degree jumps. Small jump 15, big jump 30. And then there should be some that you know as you go around. Like, shouldn't this be 180 right here? So the fact that I'm kind of seeing that from another angle is reassuring. But all the big jumps add 15, all the small jumps add 30. And to go all the way around, and then the last one should be 360, which confirms what we know already. So for a second question we can do later, we might do like, what is the sine of 240 degrees? So the fact that we now know where 240 is, we know what spot to be looking at. That's always going to be step 1. Know the location. Now, so the angles can be in degrees, or they can be in radians. So this is my trick to do this, and I think this is what works best for most students. Again, it's just an option, but until you decide that you want to run with it a different way, stick with this. Okay, I know if the angle doesn't open up at all, it's 0 radians here. And because we've done a little bit with radians in the first section, I know how many radians is halfway around.
Pi.
Pi radians. Now imagine, and this is just my suggestion, imagine this pi radians cut into 6 equal slices. Can y'all visualize the 6 slices? 1, 2, 3, 4, 5, 6. You see how we can cut this pi radians into 6 equal parts? Get this out of the way. Then that first slice is at 1 pi over 6, where I cut it into 6 equal parts. Add that much again, you get to 2 pi over 6. Add that again, you get to 3 pi over 6. Add it again for 4 pi over 6. Add it again for 5 pi over 6. Add it again for 6 pi over 6. The only other thing I did is I reduced my fractions. I'm not going to call this 2 pi over 6. I'm going to reduce it and call it pi over 3. But I'm really just adding that same angle every time. Memorize where pi over 6 is. Add it again for 2 pi over 6. Add it again for 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. And you can even continue that down here. Add it again for 7 pi over 6. And then 8 pi over 6. 9 pi over 6. 10 pi over 6, 11 pi over 6, and then 12 pi over 6. And what is 12 pi over 6 reduced to?
2 pi.
2 pi, which is what we know should be all the way around. So we get that confirmation doing it this way too. Now notice that lands almost every radian that we expect you to memorize. We only skipped a couple of them. So we need one more little trick, which is, if you know, same idea, but instead of cutting this pi into 6 equal spots, or 6 equal slices, I'm going to cut it into 4. So there's a fourth, second fourth, third fourth, fourth fourth. So I'm going to, now I know how much 1 pi over 4 is from here to here. And I can add that again to get to 2 pi over 4. That reduces and confirms what we already know. Add it again, you get 3 pi over 4. Add it again, you get 4 pi over 4. We already knew that one. Add it again, 5 pi over 4. Add it again, 6 pi over 4. We already knew that one. Add it again, 7 pi over 4. Add it again, 8 pi over 4. 8 pi over 4 reduces to 2 pi, which we know is halfway, or all the way around. So simply knowing how much 1 pi over 6 is, you can just count to where you need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You just reduce. And knowing where 1 pi over 4 is, 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8. And reduce those. And you get all of the radian locations. So when we come back and do 5 pi over 4, now we know we're looking at this point. 240 degrees, we're going to look at this point for this second made up question, and we're going to look at this 5 pi over 4 for the first one. But if you need to know something about 5 pi over 4 and you're looking at 7 pi over 6, you're going to get the wrong answer unless you're just lucky. But. Okay, and then the easiest of the points, so that's the first step, is always getting the correct location. The second step is always going to be labeling the points though. Well, the easy points are these that go straight up, down, left, or right. Because if this is a unit circle, if all of your distance is going right, this point is at 1, 0. If all of your distance is going up, this is 0, 1. If all of it's left, and if all of it's down. So people don't tend to struggle with those very much. Alright, now here's where the stuff that we did on the front side hopefully will pay off for you. I compared 5 different numbers. I said 0 was the absolute smallest and 1 was the absolute biggest, but we kind of know those already. And then I showed you the 3 other decimals. 1/2 was the smallest of the 3. Square root of 2 over 2 was the next biggest of the 3. And square root of 3 over 2 was the biggest of the 3. And this is how I keep from having to memorize this much. Looking at quadrant 1, I care about these 3 points. So x values, the smallest x value is 0, the biggest x value is 1, This point has the next smallest x value. So what do you think his x value should be?
Opposite.
Of these 5, what's the one that's just a little bit bigger than 0? 1/2. And then this next point has a little bit bigger x value. So it's going to be the value that's a little bit bigger than that. Square root of 2 over 2. The next point has a little bit bigger x value, which is square root of 3 over 2. And then the biggest y value is 1. But do you see how these 5 are the same thing as these 5? Smallest to biggest? That's where if you see how they compare, you're not really memorizing that. Now, same idea with the y values. If I know how these compare, the y values are going to come with the same thing too. Smallest y value is 0. Next biggest y value is 1/2. Next biggest is square root of 2 over 2. Next biggest y value would be square root of 3 over 2. And the biggest y value possible on unit circle is 1. So it works for x and y. All right. Now this point, you need to try to maybe put a star at all 4 of these points. All of these points have what's called the same reference triangle. The same x length and same y length. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. The only difference is in quadrant 2 you're going left, so x should be negative. Quadrant 3 you're going left and down, so they should both be negative. And in quadrant 4 y should be negative because you're going down. But otherwise, these 4 points have the same values. Same x length, same y length. Likewise, all the points in the middle of each quadrant are all square root of 2 over 2, square root of 2 over 2. We just have to go back and think about the signs. In quadrant 2, you're going left, so x is negative. Quadrant 3, you're going left and down, so they're both negative. And quadrant 4, y is negative. Otherwise, those 4 are the same. And then finally, if we compare these other 3 points, they all have the same x length and all have the same y length, so they're all 1/2 square root of 3 over 2. You just have to think about the signs. Quadrant 2, you're going left. Quadrant 3, you're going left and down. Quadrant 4, you're going down. But there's a lot of repetition, there's a lot of symmetry there. So really, if you know quadrant 1 well, and then you see the connection between these 4 points, the middle 4 points, and the highlighted 4 points, then you're not memorizing all the other ones. You're just being able to extract what you know about quadrant 1. Okay, the last part that you need, and so that we have an example or 2 down before we call it quits here, is remember on our front page, all of this ties back to this. When we memorize these points on the unit circle, cosine is the x value at each of those, and sine is the y value at each of those. So when I asked you what is the cosine of 5 pi over 4, I know you have it out on your paper, but you should be able to find 5 pi over 4 after you practice it a while. Because it's in the middle of the quadrant, it's square root of 2 over 2 and square root of 2 over 2. It's in quadrant 3, so they're both negative. And cosine should be which one of these two? Is cosine x or y?
Y.
Cosine is x. So memorizing that point gives you the cosine value. To do 240, 240 is going to be right here. We'll memorize the point there, and if you want sine, sine is the y value. So without a calculator, these important angles, we can give exact trig values without going more in depth. I'd love to do another handful of those questions, but for now we are just about out of time, so we'll have to pick this back up tomorrow. So finish up your thought on that, find a stopping place, start bringing my calculators back. You don't need to do anything for homework. If you have 5 minutes to scan the unit circle, that would probably be beneficial. But tomorrow we'll construct another one and start practicing some of these questions in the book and see what's working and what's not.